All right, I'm just trying to create a little short summary of what we learned in fractions and how we learned it. That can be helpful for parents to help their child studying for the test and providing extra practice. So when it comes to fractions, we're really focused on how to represent them in different ways. So one way is an area model. This could be a rectangle, or in this case, a circle. And let's say we have three things shaded in. They would identify that as 3/8. This is probably the easiest and simplest way for students to represent fractions. They're very good at it. Comes easy to them. The second way was fractions of a set. And something like this is pretty straightforward. You have, let's say it's 4 marbles, 4 counters. 3 of them are red, 1 of them is black. So what fraction of them are red? 3/4. Now, one of the things that we did when we looked at fractions of a set is we had some trickier questions that involved things like this. What is 3/4 of 16? So the way we practice doing this in class, because not all of them have the best number sense when it comes to division and multiplication, is to recreate a model like this way. So when we have 3/4 of 16, we're going to use 16 counters, and we actually physically use counters in class. And we're going to divide them into 4 groups.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
So each group represents 1/4 of the set. Okay, so because we're trying to find 3/4, we would focus on 3 out of the 4 sets. And each set has 4, so we have 4 plus 8 plus 12. 3/4 of 16 equals 12. And finally, we looked at number lines. Sometimes students struggle with number lines a little bit. The key is when we're talking about regular fractions, we're talking about a value between 0 and 1. So if we wanted to show 3/5 on a number line, the focus is, this means you have to split it into 5 parts because the denominator is 5. And the 5th part is going to be at the 1. We really focused on this idea that when the numerator and the denominator are the same, that is the same as a value of 1 whole. So if I'm showing 3/5, there's 1/5, 2, 3, 4. It's not exactly equal, but we talked about how they should be equally apart. 1, 2, 3, there's our 3/5, and that's how we would show that. So those are the 3 main ways we looked at representing fractions. Students will also need to be able to identify or show or prove that 2 fractions are equivalent, meaning they have the same value. And again, we're really focused on just being able to do it using a model. So if we take our circles here, we're going to circle those 2 pieces right there, and we're going to match that identical amount here. And we have 2/8 here is the same as 1/4. We can see that it's the same amount. We've talked about the relationship in terms of multiplication, so we have talked about that if you take 1/4 and you double 1, you get 2, and you multiply 4 by 2, you get 8. We've talked about that relationship, but if on a test, when we're talking about equivalent fractions, they'll always have a model like this to kind of use to help them find an equivalent fraction, or possibly a fraction tower as well. So on the fraction tower, if you wanted to find equivalent fractions, so let's say we find, here's 2/6. So we have 1/6 and 2/6. Then we're looking to match that line with something else. So if they follow along, this line is at the exact same place as this line. So that tells them that 2/6 and 1/3 are equivalent. If they kept going down, looking for that same line, here they would find a matching line right here. That's at the 12ths. Sorry, I'm rocking. So that's 1, 2, 3, 4 12ths. So they're going to be able to use some kind of model to show equivalent fractions. They don't need to have their times tables down pat where they can say, well, if I just like multiply the top number and the bottom number by 3, I'm going to find an equivalent fraction, and etc. But we did talk about it. And then the big thing that we also did was ordering and comparing fractions. So we looked at 3 main strategies. Okay. So the first strategy is common denominators. If I have a common denominator, I'm just simply comparing the top numbers. 5 is bigger than 3, so 5/7 is more than 3/7. Then we looked at what we can do when we have common numerators. So I have 4/10, and I'm comparing it to 4/5. We talked about how because 4/10, you're going to have smaller pieces. 4 smaller pieces is going to be smaller than 4 bigger pieces. When it's 4/5, the pieces are going to be bigger. So all we have to do here is compare the denominators, and the bigger the denominator, the smaller the fraction. And then our third strategy was looking at things and saying, well, what's half? So we know that 4/8, half of 8 is 4. So 4/8 is more than half. And we know that half of 5, most students can know that it's 2.5. And so they know that that's less than half. So something that is less than half is going to be smaller than something that is more than half. So those were our 3 main strategies. And then the third thing we discussed a lot is when you have 2 fractions and none of those strategies work, option number 4 is to use a model. And the model we mainly use is the fraction tower. So again, we practiced how to use the fraction tower. I work one-on-one with many students to help them get the hang of this. So if, for example, I'm comparing 8s and we're comparing 5/8, 1, 2, 3, 4, 5. There's my 5/8 line. And let's say I'm comparing that to 6/10. 1, 2, 3, 4, 5, 6. There's 6/10. I can see that my 5/8 line is a little bit further along than my 6/10 line, so 5/8 is larger than 6/10. So we've practiced using this fraction tower on the test. They will have access to the fraction tower and can use it to answer any questions. And so summarizing that, they might be asked to order a fair amount of fractions and put them in order. That would be like one of the most difficult things on the test. It requires combining a lot of these strategies. They've had a lot of practice on it now. I tell them to kind of start with what they know so that they know that this is the same as 1. 5/5 is equal to 1. They know that half of 6 is 3, so this fraction right there is equal to half. So they can go ahead and put 5/5 at the end. That's going to be the biggest. 3/6 is probably going to be somewhere in the middle. And then we look for fractions that are less than a half. So this is going to be less than a half. This is going to be less than a half. The other two are going to be more than half. So then compare 2/8 to 3/8. We're going to use that common denominator strategy. That becomes straightforward. 2/8 is smaller than 3/8. So I got smaller, smaller, I got a little bit bigger. And then I have 2 left, 3/4 and 3/5. Now we can use that common numerator strategy. So our common numerator strategy is the larger the denominator, the smaller the fraction. So 3/5 goes next, and then 3/4 would be a little bit bigger than that. So that's probably one of the most difficult things they're going to have to do on the test, is just put about 4 or 5 fractions in order from least to greatest. And the final thing that they'll be asked to do is to identify mixed numbers and improper fractions. And they'll only have to do it looking at pictures. So again, our focus is a lot of pictures in grade 4 because they're just getting really introduced to fractions. And we want to make sure that they understand the concept of them by looking at them. So for example, they might get a picture like this and say, can you identify this picture as a mixed number or an improper fraction? If we're looking at it as a mixed number, we have one whole, and then we focus on the second shape. So we have 1, 2, 3, 4 out of 8, 4 eighths, 1 and 4 eighths. In grade 4, we don't worry about simplifying fractions. So they're not expected to simplify that to 1.5. If a student writes 1.5 because they see that it's half of the shape is shaded in, that would be a correct answer. They would get full marks for that. But 4 eighths or 1.5 would be correct, and they're not asked to simplify. That's something that comes in later grades. And if you're doing this as a improper fraction, the idea is you see this as eighths, so it's one whole, which is the same as 8 eighths. And here we have 4 eighths that are shaded. So whether we count them or we multiply or we add 8 plus 4, we would call that 12 eighths, okay? And again, in grade 4, we're not asking them to convert a mixed number to an improper fraction without looking at a picture. So they're not going to be asked to do, oh, how do I turn that into a mixed number or an improper fraction? 8 times 1 is 8, plus 4 is 12, becomes 12/8. They're not asked to do that. They're only going to be asked to recognize an improper fraction or a mixed number by looking at a picture that looks like this, okay?